So this one's an improper integral from 2 to infinity, x e to the minus x squared. Um, First, let's just focus on what the antiderivative would be here. Um, this one can be done with just a basic u substitution. Let's let u equal negative x squared. Du would be minus 2x dx. In other words, x dx would be minus 1/2 du, which you see that actually works because you do have an x dx in there. Okay, so what we're really dealing with here is, the integral of x e to the minus x squared dx is going to be, so the x dx becomes negative 1/2 du, and the rest of it is just e to the u. Okay, so you got negative 1/2, and the integral of e to the u is e to the u. And then you could plug back in what u was. U was minus x squared. Okay, so the antiderivative there is negative 1/2 e to the minus x squared. All right. Now, we're actually trying to integrate this thing from 2 to infinity. So really what we ought to be doing is taking the limit as b goes to infinity, the integral from 2 to b, x e to the minus x squared dx, which we just figured out what the antiderivative of that function is. It's minus 1/2 e to the minus x squared. So we'd want to evaluate that between 2 and b. So I'll pull the minus 1/2 out here. So you'd have e to the minus b squared minus e to the minus 2 squared, which is 4. And if b goes to infinity, e to the minus b squared, that's going to go to 0, because that's the same as 1 over e to the b squared. Okay, so that goes to 0. What you end up with is minus 1/2 times minus e to the minus 4. So that is 1/2 e to the minus 4. And since we got a finite number there, that tells us that that improper integral converges to that value.